Thank you. So I'm going to talk a little bit about the Decant facility we have here in Pierce County. So in 2013, we got a grant from DOE to build a new facility because of the NPDES requirements had changed. And so we had a lot more, drainage infrastructure that we had to clean and inspect and maintain. And so we got a grant from DOE to build a new facility. And one of the things that was important to us is that we wanted to try to incorporate water reuse into, cleaning out catch basins and drainage infrastructure, because we thought that potable water is a valuable resource, and using it to clean catch basins, there were better uses for it. So we thought maybe we can work out a way where we can reuse that water. And so we put a water reuse system in this, which we'll go over here in a second, that we worked with the Seattle University Department of College of Engineering, where we worked with 6 students, and we came up with, a lot of ideas and different types of filtering systems that would work for water reuse. And so that's where we came up with the GAC system that River's going to talk about. But to start with, though, we have about 27,000 drainage structures in Pierce County that we have to inspect and maintain every year. Of those, we clean about a third of them. So it's a big process. We devote a lot of time and energy to that. And with that, we put together a video that I want to show you guys that kind of summarizes everything. So we'll see if we can get this to work.
Today on Inside Pierce County, we're going to go out and do one of Pierce County's dirtiest jobs. I'm going out with our crew on a Vector truck to clean catch basins. We're a neighborhood out Jam High. What are we going to do? We're going to spray around a catch basin, remove the catch basin lid, then we're going to put the tube in, start vacuuming out the material. How many catch basins are there in Pierce County? There are thousands. Okay, we've got a lot of work to do. Let's come straight back. Here. Excellent. There we go. Thank you very much for showing me that. That's a lot of work just to clean one catch basin. Well, we're going to be headed down the road. We have a whole lot more to do. So, Mark, tell me a little bit more about this program. It's a huge program.
The Maintenance and Operations Division every single year routinely inspects and maintains a wide variety of drainage infrastructure. And we do this work to improve water quality and reduce the risk of road-related flooding. Every year they do approximately 8,000 to 9,000 catch basin cleaning. So it's a lot of work every single year. It takes a lot of resources, and it's one of our major programs.
Now, Mark, I know we've got a federal requirement that is associated with this. Can you tell us a little bit about that?
Yeah, sure. It's called the National Pollutant Discharge Elimination System, also in short known as the NPDES permit. And within the permit, it has requirements that the county has to do to make sure that we improve water quality over time.
So this work will help salmon recover, will help keep the salmon clean, and protect our environment.
Yeah, that's our goal.
When our backer trucks are full, they come back to this special waste decant facility to empty themselves out. Jeff, can you tell me what this facility is about?
So this facility is used to manage and treat waste removed from our stormwater drainage system. We're going to empty the valve, we're going to back the truck up, and then Taylor's going to walk us through the process.
All right, so just flip that switch.
All these cool valves, and I'm doing a toggle switch. Ready?
Yeah, go for it. Oh man, not too exciting. Once it slows down a little bit, we'll open up the door. This is more butts, Ethan.
More butts.
Yes, up in here.
Okay.
Oh yeah.
Oh yeah, that's what we're talking about. If it weren't for this, all that would be going into Puget Sound.
Each year on average, this facility processes about 2,000 tons of vector waste and 500,000 gallons of liquid waste. The whole idea is to get the water as clean as possible before discharging to the sanitary sewer.
Awesome. Thank you very much, Jeff. I appreciate your time today. And I'd like to thank all the maintenance and operations folks for Pierce County who are out doing these very dirty jobs. And the next time you see a Vector truck in your community, you will know it is one of our keys to protecting our environment.
Okay, so we're back to the slideshow here. One of the things that when we were working on filtration systems, we had to think about pre-filtration, how we were going to get the water clean before we got to the GAC filter, because the GAC filter can get fouled easily and it's expensive. And so we really thought hard, how can we get that water as clean as possible before we get there? And so where we started the dumping pad on the top there. The dumping pad has a combination of rock and sand. And so as you saw in that video, when the truck comes in and it dumps, that water has a chance to filter out and settle out some of the solids before it gets to the pre-settling mode on the far right there. Once it gets to the pre-settling mode, it goes through a series of weirs into a flocculation tank where we mix about 20 pounds of a flocculant that works really well. We can get the water, pretty clear. And so once it's through that, then we put it through another couple of filters, and then it goes into the GAC filter, and it's really effective at reducing metals, PAHs, and oils. We also found out that it works pretty good for 6PPD-Q too, which is what River's going to talk about here next. Oh, here's some pictures that we have there. You can see on the left there, you can see the pre-settling tank, how dirty the water is. The flocculation tank, it's pretty clear when we get to it, and after the GAC, it's really clear. So works really well. Okay, with that, I'm going to hand it off to River.
Thank you, Eli, for the introduction. So in that video, Jeff is the celebrity, so you need autographs, so talk with him. So I'm just talk about our work here. As Jeff and Shelby explained earlier, the decant waste that was cleaned up, taken to the decant facility, was subject to multiple stage treatment, and that generated two streams of waste that still needed to be disposed of. So on average, each year we generate over 2,000 tons of solid that goes to a landfill. And there's an early discussion about potential what are the 6PPD-Q in that. So don't know how that answered yet. So we'll be prepared if needed someday, going to be classified as hazardous waste. And the liquid stream that is treated from the decant facility is not after subjected to treatment to a higher level. It is for reuse. But if it's not, then it goes to sewer. That is goes to the chambers of wastewater treatment plant. That's where I work. And the landfill also generates leachate. That also goes to the sewer eventually, and then combined come to chambers of treatment plant and treated discharge to Puget Sound. We also are subject to MPDS permit requirement there too. Oh shoot. Hold up. What I forward this? What is this? There you go. Okay. So here's how the decant facility design is different from a standard typical decant facility. And typically for the decant, they just subject to pre-settling and further sample treatment. Because we put in flocculation and GAC treatments, the water is cleaned up to really high level. And in this case, if the carburetor use example, what is coming in is relatively high. After flocculation and GAC filtration, it's down to really low level. And of course, it's also designed to remove not only heavy metals, but also other contaminants such as motor oil, diesel, so on and so forth, TBH. Again, from this graph, you can see the level of contaminants is reduced substantially, that it can be used to wash trucks. There's a lot of already presentation earlier, a lot of background information. And we're not going to spend a lot of details on the 6PPD-Quinone. This is the emerging political concern we all cared about. The LC50 of 95 parts per trillion is kind of the standard number we cite based on scientific literature. Extremely low concentration. And the properties of chemical 6PPD-Quinone, there's a lot of study, they have a pretty good understanding of its property. So it is a fairly hydrophobic molecule. So in some regard, it's fairly easy to develop BMPs because it's concerned to stick onto everything. So back to the rationale for our study, the decant waste we know because it is the failure to transport a 6PPD-Q in the stormwater drainage system, catch-basin, captures a solid based on what our understanding of the 6PPD release. This primary mechanism is through tire wear particles. And so those tire wear particles are going to end up in catch-basins, and then in the solid fraction, when do the cleaning, is going to end up in the decanter facility. But we really don't have a good understanding of what are the levels of concentration on 6PPD-Q. That's the one of the main objective we want to understand through this study. As Shelby explained earlier, the contract was established through IAA. And the main objective is we want to really understand the mass loading at a 6PPD concentration in the decanter waste. Initially, when we proposed this study to ecology, we want to look at the total mass loading, including the fraction in solid. But unfortunately, the sediment methodology was not available, so we didn't include that. Our focus has been on the 6PPD-Q in the liquid portion that has been credited for. And because of our unique treatment system, we really don't understand how 6PPD-Q moves throughout this treatment process and how they are removed. And we really want to understand the mechanism of removal. Up to this point, a lot of the great talks earlier presentation, most are based on filtration. And our design is going to provide a little bit more in that regard, based on what we learned from wastewater treatment. So it's back to some of the basics, fundamentals, the wastewater treatment. That's our experience is in. So the pre-settling tank, or the mold in this case, is just a really simple gravitational settling based on if the waste contains heavy larger particles, it can be easily settled out, just simply sitting there. And but for the finer particles, we predict that if we don't allow enough settling time, it's not going to settle. So our projection would be the 6PPD-Q attached to this large solid particle can be quickly settled out. It's going to be removed. The finer particle that's 6PPD-Q associated with the finer particles is not going to be removed easily in the pre-settling tank. And we also hypothesize that if 6PPD-Q is dissolved in water, this simple liquid solid separation is not going to remove that. The second stage of treatment, flocculation. Again, this is a really common process in wastewater treatment. The mechanism of removal is fairly straightforward. 6PPD-Q, or the finer that potentially attached to the finer particle, they tend to carry a negative charge. That is the nature of these contaminants. And flocculant is really, or coagulant in this case, is it just cationic charged chemicals? If you were to push cationic charged flocculant, it's going to react really quickly with the anionic charged particles. That's going to form larger particles. So the first stage of pre-settling based on gravitational force is going to be settled here fairly easily because it's forming larger particles getting heavier and be settled out fast. But that's our hypothesis. Again, the dissolved fraction we predict is not going to work in this stage. Just the nature of solubility, liquid is not removed in this stage. And the third stage of treatment, the GAC treatment, again, we have a lot of experience in wastewater, GAC, granular activated carbon is one of the mostly employed absorbent that is used for removing organics in particular. It's a very large market, it's drinking water, wastewater. We use a lot of those for our application. The mechanism of GAC removal is based on the super porous structure. And it has a really high surface area. Sometimes can be as high as 1,000 square meter per gram. As organic, this love just attached onto the surface of GAC. And it's a very high surface area and it has very high removal capacity for organics. And in the wastewater world, when we design a GAC treatment system, there is a removal capacity of, this is a standard specification, is it can remove organics as high as 15% of our weight. So it's a really high removal capacity. That's our prediction for 6PPD-Q. So the scope for the work with ecology was to develop just all the ecology-funded product as a farm process to develop. And we also wanted to understand if the removal capacity of GAC, we know is high, but we have we have had old bed GAC in place because it's in service. We want to replace that. We start new. And we will develop a testing plan working with the Mel Lab. They are one of the two credit laboratory at that time, in addition to King County. Now I understand the state of Tacoma credit for that too. And we also will deliver a final report, which we did already. This project was carried out in 2024. So the sampling plan to minimize cross contamination because of the level of 6PPD-Q, we don't know exactly what the concentrations are, but it's going to be fairly low. So we started in the reverse order of the treatment process. GAC first, back to flocculation and back to pre-sediment tank. Really, the water treated, wastewater treated throughout the system is from, we use high suspended solid as a measure, is the highest in pre-sediment tank, the second highest in flocculated tank, and GAC filtration is going to be further. So I'm going to move this very quickly. I don't have a lot of time. So this is the first set of data. It's very exciting when we receive the result. The 6PPD concentrations in the decanted waste in the liquid portion is about 80 parts per trillion. It's not super high, but it's near LC50, so still toxic to coho salmon. After flocculation, it's removed down to about 50 parts per trillion, which represent about a 30% removal, 30 to 40%. But after GAC filtration, it's reduced substantially to below 2 parts per trillion, which will represent a 96% removal, which is pretty remarkable, considering the first set of sample was done with older bed of GAC that has been in service for 2 years. And it treated, we did a quick calculations about 20,000 bed of volume of salt water. So it was quite impressive. So the study carried on for last summer for 3 months. We had our sampling plan for the lab called for bioliquid sampling. The result shown here, it does show variability of 6PPD-Quinone coming to the Decant facility, varies from 50 to 143 parts per trillion. The one data that is highlighted in yellow, August 8th, I think there's a data error, a sampling error, so we didn't use that because the data was reversed. Looks like we didn't use that for the future data analysis, but it consistently shows that the multiple stage treatment removes 6PPD-Q on average anywhere between 96% to 98%. And the flocculation tank, after flocculation treatment is average about 30 to 40%. So this is really the summary of the overall removal, combined removal, from recycling tank, flocculation tank, and to the final gag filtration. It's very high. System solid is also as expected to be very high. But we really don't see a great correlation. Gosh, obviously. With the 6PPD testing being so expensive, we wanted to see if you can use similar parameters to predict the 6PPD concentration, simply just measure TSAS. And we didn't see a very good correlation. So I'm going to move through the slides. The study is already published by Ecology. If you want to look at the details, reach out to us to look at it in more detail. So this just shows there's no correlation, but I wanted to bring this one up because with a pretty remarkable performance of gas filtration, we wanted to see if we were to send pre-settling tank of stormwater that has not been treated with a flocculant, would we achieve the same removal? So we did a fairly simple column study. We compared high performance BSM, GAC, as a perlite we use as a control. But there's a lot of studies that previously shown that the inorganic absorbent doesn't really work well. We predict that's not going to remove 6PPD very effectively. So HPBSM and GAC compared really surprisingly, if your stormwater sample is heavily contaminated, the removal is really significantly impacted by the article contaminants. And that is something you really should keep in mind. Even though GAC demonstrates remarkable performance, we have to take into consideration how do we pre-treat to remove article contaminants from failing the GAC. The reason that the deterioration of performance with you have so much suspended solid article contaminants is because this pores really tiny. If you have suspended solid, it's going to fill those up, going to fill the pores. It's not going to be available to remove CPPD-Quinone anymore. That's based on our data. So again, back to what we just discussed, the settling and flocculation remove the solid really well, total solid really well, but it's only removed 6PPD to some degree partially. That tells us that 6PPD-Q is really distributed in both liquid portion and a solid portion. So solid removal can only remove the fraction that attaches the solid, but it does not work well if it's dissolved. A GAC did the trick. And based on our understanding, that makes perfect sense. So moving forward, when we were to think about applying GAC, include that in our BMP design, we really want to be mindful of providing pretreatment to treat suspended solid or anything that comes with salt water. Let the GAC do its magic trick of removing the soluble fraction. You're going to get a really combined, you get it really the best removal. I think that's close to our. We also try to correlate the 6PPD concentration to our cleaning activity, because the Arizona is a really large incorporated area. We have a low traffic area, high traffic area. We didn't see a very good correlation, so I'm going to just skip this. There is a modeling that probably we're going to do a better job predicting what are the 6PPD concentration in the catch-basin. But the last slide I want to throw in. So a lot of BMPs existing or under development is really based on the mechanism of filtration. It's just physical removal absorption. So as a chemist, if you look at the chemical structure, you have this carbonyl functional group, Yeah, it is subject to chemical reaction, so I want to encourage folks out there to think about, not only just to remove 6 feet physically absorb, sooner or later, you're gonna reach the removal capacity, you're gonna see breakthrough. As our preliminary column study did show that, if we have breakthrough, it's not gonna remove 6 feet anymore. So you really need to move forward thinking about potentially permanently grab onto 6 feet afford as a permanent removal. That's just, I want to throw something out there for people to think about. So with that, that's our presentation of the study. Open for questions if you have any. The combination of both. From what we understand, the data shows the solid separation through gravitational settling and flocculation. We see 98% removal solid, but there's still a very large fraction of 60 PQ remaining. That it tells us it's dissolved in the liquid phase.
That question was about the process
Yeah.
of 6 PPD.
Removal.
And-
Yeah, so GAC has a simply physical absorption. So GAC is a large, almost like a graphene structure, graphite. This is a ring structure, it's fairly hydrophobic. So 60PPD-Q is also fairly hydrophobic, just like a TPH. So it's going to be just physical attachment. There's a fascinating term called the van der Waals force. It's just physical interaction. It's not a chemical reaction. That's it. The preliminary study was done in a column, small column, lab scale. But as far as you're talking about the quality of gap, is it the same type as the filter zone from a couple of carbon? I'm not sure if is it one?
So I think the question was, does the comparison to the high performance BSM, was that the column study?
Yeah. Yeah, that was a column study, yes.
Just the pre-settled or the pre-settled water just through GAC only.
Yes. There's no flocculation to be, the system when it's only that particular example is 245 milligram per liter, so it's really heavy. That's kind of extreme. I don't foresee our stormwater is going to be that high in system when it's solid. But maybe in some of the first flush, we would expect fairly high. So that's why we would advise if you want to permanently incorporate GAC in BMP, really it's essential to take care of that interference first. Firstly, we do have a lot of basic treatment that has been put in, for example, contact, ADS, that has been gone through the tape process, and it can remove TSS 80% that should be clean enough. So our consideration may be to include a second stage of GAC, just polish it up on top of basic treatment. We may look into that in the next phase of our study.
I think that's gonna be the next phase of the project, and yes, we do have street sweepings and the factor waste there, so there's both of those are in there, but the street sweepings weren't really involved in this, we tried to keep them separate.